right, hello again. I would like to welcome back this morning's panelist, Chris Dennis, Chief Mechanical Officer for Vaughan Fire and Rescue Services, to talk about cryogenics. All right, Chris, I'm going to hand it over to you.
Laura, thank you. That was a wonderful presentation by Rob Anselmi and the folks from Rev Group. Appreciate that. Okay, so we're going to talk about cryogenics. For those of you that have used it before, you may be familiar with an Austin Powers movie or a dinosaur movie where at some point in time something was locked in and held in a frozen state for some length of time. Well, this particular component that I'm going to talk to you about almost does the same thing. Properties behind cryogenics. Again, I'm a mechanic. I'm not a metallurgist. I'm going to be name dropping as we go along with some people that are definitely those that are very well versed in this particular case for a lot more information. The form of cryogenics is actually taking a material, in this case, we're going to talk about metal, and dropping the temperature in that particular product to a specific temperature down, well, in excess of minus 320 degrees Fahrenheit or minus 190-ish degrees Celsius. It's done through a liquid form. What this does to the product is actually change its molecular structure. So metal, when it's poured into its form, is of a raw state, and as the product is made and that metal is taking shape, it cools, and as it's cooling and coming to a state in which it can be used, the product's molecular structure changes, and as it changes, so does its capability of moving heat. So I'm going to talk about brake rotors. Brake rotors on fire trucks and drums in particular, as well as on vehicles we drive over the road every day, all create an awful lot of friction. For those of you that are race fans and watch the Indy races or Formula One races, you can actually see that the turbochargers and brake rotors actually glow red after multiple brake applications. These particular products that are glowing red have been treated in some way, shape, or form to be able to stop the vehicle. Technology, as we've been discussing throughout the day today, has changed as well. Some of the modern manufacturers, as well as European manufacturers, are using carbon fiber components on their brakes strictly for weight and to be able to dissipate heat. Very, very expensive. Corvette is using, in some cases, are using carbon fiber brake rotors, as well as high-end imports, as I mentioned, and where you could maybe buy a brake rotor for your Corvette off of something as simple as Amazon or from the dealer for a few $100s is now a couple of thousands of dollars, $2,000. Every manufacturer is different. Back in 2005, I met a gentleman from Hamilton Fire, Rob Kay, again, my cohort, the chief mechanical officer there. And back in 2001, Hamilton Fire had started doing cryogenics to the ambulance side. The particular issue was, especially with ambulances, is they're not operating on air brakes, they're working on hydraulic brakes. And again, just like our cars that go up and down the road today, fire trucks, depending on the class, whether it be class 7 or 8, not necessarily 6, we are dealing with air brakes. So I'm going to go backwards here. 2005, it was introduced to Hamilton, and what they found is that they were actually able to not only virtually cure brake pedal fade, but be able to have components last a lot longer. When I heard about this, I spoke with Rob, and that happened to be at the Ontario Fire College. And he went into great detail to explain to me his passion towards cryogenics, and hooked me up with a company called ICE, which was Industrial Cryogenics. And they are still available and still around today. What we did is we took a look at, in my particular case, the time and the expense to do a brake job on a disc brake powered vehicle, which is what we have, and the length of time that we were getting out of brakes on a busy station, busy apparatus, especially our heavy rescues. From annual safety inspection to annual safety inspection, we would take anything at approximately 50% and not roll the dice and perform a full brake job. We would also be up against consistent braking evolutions where we'd actually have wheel end fires. And when we had wheel end fires, we had all sorts of other fallout from those wheel end fires, from calipers being burnt, airlines being burnt. Thankfully, not a complete truck, but a lot of damage done at one end. So cryogenics brought a different look to how we do our business. So the cryogenic process, and again, there's many different ways, but I'm going to refer to another gentleman named Jack Kahn, who, if you go online, sorry, I'm going to look at it. He's out of Lunenburg, Nova Scotia, is definitely by far the guru in cryogenics. He does what's called deep cryogenics. So what this does to the metal is it takes it from its natural state. In this particular case, the vessel that it goes into is about the size of a washing machine. And it doesn't necessarily mean what the part is. It has everything to do with its size and its weight. So our brake rotors go into this particular machine, and this machine, over a process which was anywhere between 36 hours to 72 hours, was an entire process where the brake rotor would be left in liquid nitrogen, would be taken down to an excess of and in around minus 320 degrees Fahrenheit, where it would be left at that state. It's kind of the secret recipe here, like KFC and some other, maybe your grandmother's special recipe that was kept rather close. So cryogenics would then take the molecular structure of that metal, we'll call it rotor, and actually loosen it up. So when I say that, again, I'm not a metallurgist, but the particulate that's in there would actually be freed up to the point where they're no longer touching or overlapping. So we're going to call them molecules, for lack of other words. So much like we as human beings, when we're cold, if we were to huddle together, we would be able to create a lot of heat huddled together. But cool it down and spread us out, then that heat is no longer easily channeled because they're further apart. And this is what the liquid nitrogen does to the molecules. It actually keeps them away from each other. And then once they're in there for its allotted time schedule, the warm-up process starts. And the warm-up process, as I said, based from my learnings from ICE in particular, and what I've read with Jack's comments, is where the magic happens. So as it's warming up through its regular ambient temperature, those molecules are actually staying separated. They're no longer touching each other. So as it gets warmer and warmer to the part where it's actually mechanically treated to warm up, the part is brought back to its natural state, only lightly modified by its molecular structure. Still looks the same, the color is still the same, the weight hasn't changed, and the biggest thing is it hasn't altered any of the manufacturer's warranties. Excuse me. So what happens now is that brake part ends up back on the truck, and when it goes back together, and the first brake applications made, there's heat. And when the heat is transferred through the brake pads, which are also made out of a metal product, or the brake shoes for that matter, with metallic particles in it, the rotor or brake drum is also heated. So we'll step back. When we talk about those molecules in an untreated rotor or brake drum, those molecules are touching. Well, how many of you have ever experienced it with a fire truck or with an ambulance or with a car or your own pickup truck after a hard brake application, or as the vehicle is getting older, you put your foot on the brake and you feel that pulse. It just feels like the car is going over bumpy road over and over and over again until it comes to a stop. That's caused by a few things. I mean, warping used to be the big thing. On my days on the bench, you had to be a specific torque setting to not warp a rotor, especially on the ones that were free floating. What the cryogenic component did is it actually, by keeping the molecular structure of the molecules apart, didn't allow them to superheat together. So that pulsation you were feeling, once those molecules were heated, the ones that were untreated and touching each other, they would actually then become even harder, and they would become harder in that one spot. So from a technical standpoint, or as a mechanic, if you've taken brakes apart or clutches for that matter, and pressure plates or intermediate plates, and you see bluing or hot spots, excessive heat buildup. And in most cases, it's because those molecules there's large groupings of them, and they've actually superheated together so much that they're actually have created a hard spot that turns into a high spot on that brake drum or rotor. So when you're applying the brakes, you end up with that pulsation. So by the cryogenic treatment, we have actually been able to eliminate that happening. We've actually been able to make brake rotors and drums last almost 3 times longer than what we were doing in the past. By doing this, not only are we saving money, our inventory, because we keep a decent inventory based on the what ifs, I'm only able to stock 1 complete set of cryogenically treated parts because I know when it's needed on a standardized fleet that I'm going to be able to put them on and not have to worry that the next day I'm going to need another one because of an excessive brake application. We even actually went as far as to cryogenically treat brake pads and brake shoes. And we actually found that we were getting a little bit lazy in checking our brakes. So we stopped doing that, and we're still gaining almost 2 full years out of a front run truck, which equates to almost, well, today's price is around $2,500 a wheel end. When you're talking about pads, rotors, let's take your mechanic's time, which is precious, especially with the ones that we have or don't have, as well as their physical being. You're not beating your technician up, slugging all these heavy parts. Brake rotors, depending on the manufacturer, studs have to be pressed in and pressed out. It's rather tedious. So we're actually able to take the downtime and completely change that. And a hydraulic brake application, again, Hamilton Fire put it together, where they took ambulances and they did 3 emergency stops. These are with hydraulic brakes, so brake fluid. And they did 3 emergency stops, all back to back and all at the same speed. The average temperature on any brake failure is in excess of 750 to 760 degrees Fahrenheit. And on those 3 stops, they were able to achieve that. And with that came brake pedal fade. With the cryogenically treated components, same setup, 20 mile per hour stops 3 times aggressively. We were now down to the better part of 360 degrees Fahrenheit on the same application. So what that meant is we ended up with, again, there was no such thing as brake pedal pulse, but the biggest savings, especially with hydraulic brakes and especially with ambulances, we no longer had what's called brake pedal fade. Hopefully you've never ever experienced it, but if you have, it's a very sobering moment when you put your foot on the brake pedal and there's nothing there. The vehicle just wants to keep on rolling. Because what ends up happening is you end up actually superheating the brake fluid so many times within the caliper itself that it exceeds its own boiling point. And when that happens, it creates a gas and you can't compress, unlike materials. So you can push your foot on the pedal, but it's not compressing, and we end up with a poor brake application. So I extended it one step further. I thought, boy, oh boy, if friction seems to be the biggest problem, I had a truck where we were using back in the day a pack brake, or the engine brake was actually an exhaust brake, and when it was activated, it actually would shut the exhaust pipe off, like putting a potato in the tailpipe, and would revert the hot exhaust gases back against the compressor side of the turbo or the wheel itself. And within a couple of years, I was replacing turbochargers pretty much on a regular basis with this one truck. I can honestly tell you I've never done it again. But what we did is we took that turbocharger and I had it cryogenically treated, dismantled, and then cryo treated and reassembled. That truck went 4 years on the same turbocharger right up until when we retired it. So again, it was a huge savings, not only in dollars and cents, but in man downtime and possibly a truck failing on the way to a call or coming back from a call. I did the same thing to chainsaw blades. The edge of the chainsaws against when sharpened, if you look at them when you've gone through steel, as well as bounce them off a few beams, if you're not chipping those teeth off, or whether it be a bullet chain or a carbide chain, you know, you're excess of $400 for a small amount of money. It's actually usually charged by the pound. You'll end up with a chainsaw blade that will last twice as long. So the cryogenic process, again, is quite extended. I really don't know if there's any much more, Laura, that I could go on about, other than if there's any questions, then I'd be more than happy to answer what I can. I can tell you that I've been approached on a couple of occasions now by some of the OEM manufacturers that build brakes to ask me how things are working. I can also tell you from 2005, when I first started looking into this, that a lot of the tool manufacturers are now offering ice treated, I call them ice treated, but they're cryogenically treated saw blades. So in the fire service, we use Sawzalls for a lot of things and a lot of different blades. So you can actually now buy them where they'll say on them ice treated or cryogenically treated. So for us, it's been a huge dollar savings. I can honestly tell you that I have not had to replace a brake rotor due to a wheel end fire in excess of 15 years. We still take them off, though, every annual safety inspection. We don't mess around with that, but it's been a huge cost savings. I highly recommend it on anything that creates, in metal in particular, that creates friction in our business. Thank you.
All right. Thank you. While we're waiting for a question to come in, is it difficult to train how to do this?
Great question. So there are a couple of facilities that I'm aware of here in Ontario that are doing it. And one of them is the company that, again, that we used, Industrial Cryogenics. There was a couple of other ones that had come out back in the day. The equipment they have is specific. So you could possibly buy it. I have no idea what the cost is. And depending on the size of the item, it could be rather costly. So for example, Deep Cryogenics has prided themselves on the industrial market. So we'll talk about mining and apparatus, where you've got the big diggers and the claws, and when they're out in remote areas, when those items break down, it's man hours and time to get the parts in. And if you look into it again on their website, which is deepcryogenics.com, there's some really great stories that talk about the machine itself, where the mining companies have actually bought the machine. It's the size of a sea container, and they're able to put those large pieces of equipment in to have them treated. In the event they have a breakdown, then they've got them readily available.
All right. Well, we are pretty quiet on the question front right now.
It's just it's a really weird thing to look at. I mean, from a mechanical standpoint, from a whether it be the private sector, whether it be a volunteer fire department, or whether it be a full-time department, um, the initial cost is, as I said, is based on today's prices. The most recent invoice I haven't seen, but we're probably close to about $2 a pound. So if you take a brake rotor and call it 100 pounds or 80 pounds versus the replacement cost, and some brake rotors can be super expensive depending on how you spec your trucks. It's worth the money, not only again for the cost savings for budgets, but just you're not beating up your technicians because they're not being tied up doing a brake job when realistically, or a full-blown brake job, and realistically all they would do is what we call a pad slam in a service. That could take a couple hours on a wheel end versus half a day.
Okay, so this is a solution that could work for kind of any size department, would you say?
100%.
Yeah.
Yeah, 100%. Depending on the facility, or again, I'm not one to sell the OEMs or to to boost businesses. But as I said, it's a company that I used, and I can call them on a Tuesday or on a Monday. They come by on Tuesday or Wednesday. They'll pick everything up that I have, whether it be one chain or whether it be one rotor or a bunch. And I'll usually have it back in a week. So I say that because of location, distance, and I pretty much have one of everything that I would have cryogenically treated on the shelf. So if I've done a tandem brake job or 6 wheels, I will purchase 6 more of the drum or the rotors, have them sent out, and have another one on the shelf ready to go.
Makes sense. All right. Well, we're still pretty quiet on questions. Do you have anything else you want to add?
At this time, no. As I said, I enjoyed myself this morning as well. That was wonderful. For those that didn't see it, and you can look later because it was recorded, that'd be great.
That's right.
As I said, I enjoyed the comments that were made by Chief Anselmi in regards to the Vector truck. We at Von Fire are new into the EV world ourselves. We are taking delivery of 3 new trucks this year. They are REV chassis, but they are not Vectors. They are E1s with conventional noisy diesel engines. But the generation of the regeneration systems that are on them are actually lithium batteries. So we are going to be moving to a greener avenue, and we'll be waiting to see how well the Toronto trucks work. Excuse me. And again, I'm being our trucks are pretty much standardized, being the Spartan or Smeal or Rev Group chassis build in most cases. Being standardized, I hope to have an opportunity as well when we get down to do the final inspection on our new ones to see that Vector truck up close.
Yeah, absolutely. I think everyone is really excited to see one up close, aren't they?
It's going to be different not yelling at your crew commands when the truck is so quiet on the inside.
Yeah, for sure. Well, thank you for that great presentation, and again, for your time this morning. You've been a huge help with our event today.